All right, so let's do an example here where it's not completely clear what tool we're going to use, but we'll figure out which is the right tool. All right, so here's the question. How many ways can we make change with 10 coins, and we're going to use a specific coin set in the sense of what coins we're allowed to use. Let's do pennies, nickels, dimes, and quarters. Okay, and you can modify this problem to maybe include 50-cent pieces too if you want, or even dollar coins. All right, so this is just our coin set. We have 4 possible coins to use, and we're going to use 10 of them, and we're going to ask how many ways we can make change. To make sure the issue doesn't get too cloudy, I want to give us a little bit of an out here. We're going to consider a different change to be a different coin set. Okay, so again, one of those things is the language can be a little ambiguous. And I think this one, it's hard to get any clarity until you decide on what the issue is. Because you could take change to mean the value of the 10 coins. But for us, we're going to simplify it. We're just going to talk about one way of making change is just this set of coins, and then another way of making change is another set of coins. All right, so let me give some examples of outcomes. So examples of outcomes here. I'm going to use the letter P for penny, N for nickel, D for dime, and Q for quarter. They're different. So an outcome could be, I could have, say, 3 pennies. I could have, say, a nickel. Maybe I don't have any dimes, and so that means I have a bunch of quarters, right? So I have 6 quarters. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's one outcome of 10 coins. Right, or maybe I could have a penny, maybe 2 nickels, 2 dimes, and then maybe let's do 3 dimes, right? And then maybe 4 quarters. Let's make sure you have 10. And you could brainstorm some others, right? And you could be missing certain coins, or you could have maybe 10 pennies. One thing to notice here is I put them in order from ascending value here. If I had just mixed these around, like to take this outcome, right? Maybe I've done a dime, a penny, a nickel, a quarter, a dime, a quarter, 1, 2, 3, 4, 5, 6, 7, 8, and even another dime, another quarter. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 10 letters there. Hopefully I have the same letters. I mixed it up, but this is the same outcome. It's just the coins rearranged, but it's the same change. It's the same collection of coins, just in a different order. And this does not make a different outcome. So totally scrambling around doesn't do any good. So the trick here is to realize that maybe it's not the different coins that are important. It's the amount of each coin that is important, right? And that's a pretty subtle difference, if that even makes any sense, right? It's the fact that I have 3 pennies, 1 nickel, and 5 quarters that makes this outcome that outcome. All right, so hopefully putting this in order does suggest a strategy, though. If I was just to decide ascending order is the arrangement I'm going to use to classify outcomes, then I can actually turn this into a bin filling problem. Okay, so this is a bin filling problem. Okay, believe it or not. Okay, so take a moment with your brain and think, okay, how many objects am I going to distribute? How many bins do I have? And from that, how many dividers do I have? All right. Okay, so the objects are actually the number of coins, right? It's like a almost like a flyer. So we actually have 10 objects. Probably, if you're just taking guesses, that's probably the right thing, but that is true in this case. All right, bins. Well, it turns out that we have 4 bins. And if you just kind of start thinking backwards a little bit, if you're talking about 4 bins, you can almost think about these as like being blank objects. And then you turn in the blank objects into the bin, and the bin feeds you one of those coins. So like, again, this is just a visual game. Right, so you kind of have your penny dispenser, nickel dispenser, dime dispenser, and quarter dispenser, and you have like 10 tokens, or identical tokens, and you feed them in these different things, and it feeds you out pennies, nickels, dimes, and quarters, right? So like a 10 tokens, identical tokens that you feed in, and you get the coins out. Right, just a visual to help play with making the connection a little more concrete. All right, now to get your dividers from bins, it's 1 less, so 3 of them. I don't know why I'm saying it again, being redundant. All right, 3 dividers. All right, so we take our objects and dividers. So we have 10 plus 3, and that gives us 13 blanks. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 blanks. And you would need to choose either 3 of them to be dividers or 10 of them to be the objects. And I think choosing dividers often makes the most sort of just sense in the narrative of what you're doing. It feels more natural. But you can also choose the objects. So if I chose 3 spots for the dividers, suppose I wanted to do this to make sure I get this first outcome. Well, that means my divider goes in the 4th blank, right? Because I want a few pennies. And then I need another divider after 1 nickel. I have no dimes, so I need another divider there, leaving the quarters. Right, so this, without the P's and N's and Q's and things, would look just like this. But you can see, if my X's are tokens, I would feed 3 tokens into the penny dispenser and get 3 pennies, 1 token into the nickel dispenser and get a nickel, no tokens into the dime dispenser, I'm skipping that one, and 5 tokens into the quarter dispenser, and ta-da, end up with this outcome right there. Okay, so this word is complete and not ambiguous or anything. It's complete instructions on how to construct this outcome. All right, and there's 13 choose 3 ways of doing these based on this sort of construction here. All right, so the general way of doing this, if you need a formula, it's number of identical objects plus dividers, and you can just remember this is bins minus 1. Choose, and then using this formula, this is bins minus 1. Okay, so that's the formula and sort of with words in the spots where it goes. Okay. So we'll continue to do examples of this sort and start to kind of mix together. When is bin filling appropriate? When is permutations appropriate? Do these things mix together? Yes, they do sometimes, so we'll play with that. All right, so I'll see you in the next video.